Welcome to our channel. Today we're diving into the mysterious and mind-bending world of black holes. Get ready to have your mind blown by some of the most unique characteristics and bizarre science facts about these cosmic phenomena. You see, black holes stand as a testament to the universe's power to warp the very fabric of space-time. They challenge our understanding of gravity, of light, of time itself. And as we gaze out into the cosmos, seeking to unravel their secrets, we're essentially peering into the universe's ultimate frontier. Over the next few chapters, we're going to journey together into these realms of extreme physics. We'll explore how black holes form, what happens when you get too close to one, and the profound implications they have for our understanding of the cosmos. So buckle up, space cadets. We're about to embark on a thrilling ride through the cosmos where the laws of physics as we know them get stretched, twisted, and perhaps even broken. Let's get started. Black holes. Just the name itself conjures up images of cosmic abysses, regions of space-time so extreme that they defy our everyday intuition. And for good reason. These objects represent the ultimate victory of gravity over all other forces in the universe. Imagine, if you will, a place where matter is squeezed so tightly, so densely packed, that it literally disappears from our observable universe. That's the essence of a black hole, a region of space-time where gravity is so strong that nothing, not even light, can escape its clutches. But how does such an extreme object even form? Well, it all begins with the death of a massive star. Stars, these giant balls of burning plasma, are engaged in a constant battle against their own gravity. For most of their lives, stars maintain a delicate balance, their outward radiation pressure counteracting the inward pull of gravity. But when a sufficiently massive star exhausts its nuclear fuel, this delicate balance is shattered and gravity reigns supreme. Black holes are some of the most extreme objects in the universe. The concept dates back to the 18th century. In 1783, John Michel proposed dark stars with gravity so strong they could trap light. Michel's ideas were based on Newton's law of universal gravitation. In the early 20th century, Einstein's theory of general relativity revolutionized our understanding of gravity. He described gravity as the curvature of space-time caused by mass and energy. This led to the prediction of black holes, regions so warped by gravity that even light cannot escape. Black holes, those gravitational behemoths of the cosmos, aren't one size fits all. Oh no, the universe loves variety, and black holes are no exception. We've got stellar black holes, the remnants of massive stars that have gone supernova, collapsing in on themselves under their own immense gravity. Imagine a star, many times the mass of our sun, burning through its nuclear fuel. Eventually it runs out of fuel, and the outward pressure from nuclear fusion can no longer support its massive weight. Gravity takes over and the star implodes, collapsing in on itself in a spectacular supernova explosion. What's left behind? A region of space-time so dense with gravity so strong that nothing, not even light, can escape. That, my friends, is a stellar black hole. These stellar remnants are scattered throughout galaxies, including our own Milky Way. And just how massive are these stellar black holes? Well, they typically pack a mass about 3 to 10 times that of our sun. That's a lot of mass crammed into an incredibly small space, creating a gravitational pull unlike anything we can imagine. But if you think stellar black holes are impressive, wait till you hear about supermassive black holes. These cosmic titans lurk at the centers of galaxies, including our own Milky Way, and they make stellar black holes look like cosmic dust bunnies. We're talking millions, even billions of times the mass of our sun. These are the true heavyweights of the universe, and their gravitational influence shapes the galaxies they inhabit. How they form and evolve is still a mystery, but we know they play a crucial role in the life cycle of galaxies. Imagine the gravitational pull of billions of suns concentrated into a single point. It's mind-boggling. And yet, despite their enormous size, supermassive black holes are incredibly compact, occupying a region of space smaller than our solar system. Now, you might be wondering just how far away is the closest known black hole? Well, in astronomy we measure distances in light years, the distance light travels in 1 year, And let me tell you, light travels fast, covering a mind-boggling 5.88 trillion miles in a single year. The closest known black hole to Earth is V616 Monocerotis, lurking about 3,000 light-years away in the constellation Monoceros. That means the light we see from it today left its source 3,000 years ago, back when ancient civilizations roamed the Earth. That may seem like an immense distance, and it is on a human scale, but in the grand scheme of the cosmos, it's practically in our cosmic backyard. To put it in perspective, our Milky Way galaxy is about 100,000 light-years across, so V616 Monocerotis is relatively close by. But don't worry, there's no need to panic. V616 Monocerotis poses no threat to Earth. It's not on a collision course with us, and its gravitational pull, while powerful, is negligible at this distance. Black holes, those enigmatic denizens of the cosmos, aren't just static objects sitting idly in space. Oh no, they're dynamic rotating behemoths, and their spin can have some pretty mind-bending effects on the fabric of space-time itself. You see, as a black hole rotates, it drags space-time along with it, like a spinning ball dragging a sheet of fabric. This phenomenon, known as frame dragging, was predicted by Einstein's theory of general relativity, and has been observed by astronomers studying the behavior of matter near black holes. Imagine a cosmic whirlpool, space-time itself swirling around the black hole. Now, the faster the black hole spins, the stronger the frame-dragging effect. It's like stirring a cup of coffee. The faster you stir, the more the coffee swirls around the spoon. This swirling of space-time has some pretty bizarre consequences. So, you're falling into a black hole. Don't worry, it happens to the best of us, at least hypothetically speaking. As you approach this cosmic monster, you might expect a big sign that says, "Welcome to the event horizon." But space doesn't really work that way. Instead, you'll encounter a region where gravity is so intense that the very fabric of space-time begins to warp beyond recognition. This is the event horizon, folks, the point of no return. Imagine a waterfall. You can happily paddle around upstream, but once you're caught in the current and go over the edge, there's no coming back. That's the event horizon in a nutshell, except instead of water, it's the relentless pull of gravity dragging you towards the unknown. Not even light, the fastest thing in the universe, can escape its clutches. Imagine being stretched like a piece of cosmic spaghetti, your body elongated and contorted by the immense tidal forces at play. Your image would eventually freeze in time, forever trapped at the edge of the abyss. Time. It's the one constant in the universe, right? Well, not quite, especially when you're hanging out near a black hole. You see, according to Einstein's theory of general relativity, gravity has a peculiar effect on time itself. The stronger the gravitational pull, the slower time ticks. This mind-bending concept is known as gravitational time dilation. So while you're busy falling into a black hole, experiencing the ultimate thrill ride, time back on Earth would be ticking by at a much faster rate. Imagine taking a trip to a supermassive black hole at the center of a galaxy far, far away. You spend what feels like an hour orbiting this cosmic behemoth, taking in the sights or lack thereof. But when you return to Earth, you find that millennia have passed. Talk about jet lag. This is because the black hole's immense gravity creates a significant time difference between you, the intrepid explorer, and those stuck on Earth. It's like something out of a science fiction novel, but the universe is stranger than fiction, my friends. Black holes are nature's ultimate cosmic laboratories. They push the boundaries of physics, challenging our understanding of space, time, and gravity itself. And one of the most intriguing aspects of these celestial objects is how they warp and distort their surroundings. Imagine a giant bowling ball placed on a trampoline. The ball represents a black hole, and the trampoline represents the fabric of space-time. Just like the bowling ball creates a dip in the trampoline, a black hole warps the fabric of space-time around it. This warping effect is what causes the bizarre gravitational lensing we observe around black holes. Light, following the curvature of space-time, gets bent and distorted, creating ghostly images and arcs of distant objects behind the black hole. It's like looking through a cosmic funhouse mirror, where reality itself is warped and twisted. And as if that weren't mind-boggling enough, black holes can also spin, dragging the very fabric of space-time along with them in a phenomenon known as frame dragging. Space is vast, but it's not always a lonely place. Even black holes, those solitary giants of the cosmos, can find themselves in each other's company. And when they do, get ready for a cosmic showdown of epic proportions. When two black holes collide, they release unimaginable energy, sending ripples through space-time. These ripples are gravitational waves, echoes of the universe's most violent events. In 2015, scientists detected these waves, confirming Einstein's predictions. Black hole mergers also create even more massive black holes. It's a cosmic cycle of destruction and creation. Black holes aren't just cosmic vacuum cleaners. They can also spew out jets of particles at nearly the speed of light. These powerful jets, known as quasars, are some of the brightest objects in the universe. Quasars are cosmic lighthouses shining across vast distances. They provide glimpses into the early universe when black holes were young and hungry. So, we've talked about how black holes are these cosmic vacuum cleaners, right? Sucking in everything around them. But what if I told you they could also be the universe's most powerful particle accelerators? You see, some black holes, especially the supermassive ones at the centers of galaxies, have these incredible jets of energy and matter spewing out from their poles. Now, we're not talking about a little bit of cosmic dust here. These jets are colossal, stretching out for thousands, sometimes even millions of light years across space. That's like a beam of light shooting out from the center of our Milky Way, reaching all the way to our galactic neighbor Andromeda. And the energy contained within these jets, mind-boggling. They're powered by the immense gravitational forces at play around the black hole, which can heat up in falling matter to billions of degrees. That's hotter than the core of our sun, folks. This superheated matter gets channeled along magnetic field lines, blasting out into space at nearly the speed of light. Now, these powerful jets, they don't just shoot out randomly. They're focused beams like cosmic lighthouses cutting through the darkness of space. And when these beams are pointed directly at Earth, that's when things get really interesting. We see them as quasars, some of the brightest objects in the entire universe. Quasars are so bright, in fact, that they can outshine entire galaxies that host them. Imagine that, a single object powered by a black hole shining brighter than billions of stars combined. It's a testament to the sheer power of these cosmic engines. We're talking about objects so distant that their light has been traveling towards us for billions of years, essentially giving us a glimpse into the early universe. By studying quasars, we're not just learning about black holes, we're uncovering secrets about the evolution of the cosmos itself. It's like looking back in time to an era when the universe was young and full of these energetic giants. Black holes, they're not just these exotic objects in some far-off corner of the universe. They've fundamentally changed our understanding of the cosmos and the very laws of physics that govern it. You see, to truly grasp the mind-bending nature of black holes, we have to turn to Einstein's masterpiece, the theory of general relativity. Einstein revolutionized our understanding of gravity, describing it not as a force, but as a curvature in the fabric of space-time. Imagine a bowling ball placed on a trampoline, causing it to sag. That's kind of like what massive objects do to space-time. Now picture a black hole, an object so incredibly dense that it punches a hole in this fabric, creating an infinite well of gravity. That's the thing about black holes, they push the limits of our understanding of physics. At the singularity, the point of infinite density at the heart of a black hole, our current laws of physics break down. It's like trying to divide by zero. The universe itself seems to glitch. Then there's the whole quantum mechanics side of things. See, general relativity, it describes the universe on the grand scale, stars, galaxies, black holes. But zoom into the subatomic world and a whole different set of rules takes over, the realm of quantum mechanics. Here's the problem. These two pillars of modern physics, they don't always play nicely together. Black holes, with their extreme gravity and infinitesimally small singularities, represent a cosmic clash between these two titans. It's like trying to fit a square peg into a round hole. This is where things get really exciting for physicists, because somewhere in this cosmic conundrum, in the marriage of gravity and quantum mechanics, lies the key to unlocking a deeper understanding of the universe. It's a quest to find a unified theory, a theory of everything, and black holes might just hold the key. From their mind-bending physics to their awe-inspiring power, black holes continue to fascinate and challenge our understanding of the universe. They remind us that the cosmos is a place of endless wonder, full of mysteries waiting to be unraveled. Thanks for watching. If you enjoyed this video, don't forget to like, share, and subscribe for more fascinating science content. Let us know in the comments which black hole fact blew your mind the most.